The A-1 Sandys are scrambled to fly cover for the Jolly Green rescue helicopter and downed airmen during search and rescue missions. Slower than fast movers, the A-1 can strike in close, delivering massive firepower, maneuver in and out, loiter over the target, and absorb heavy punishment.
Rolling in hot. Sandys, 1 and 2. Break it off. The Jolly Greens just picked up the survivors.
Well, that's how I got my start in aviation. And what we're talking about today is my generation in aviation. Basically, I got started in 1970. That's when this air rescue video was shot. And that's what I used to do. I was a crew chief on, not on the Sandys, not on the fixed wings, but on the helicopters. So 1970 to 2020 is 50 years. And the topic of today's talk is my generation and what we've done in aviation, basically from 1970 through about 2020. I want to talk a little bit about the generation before us, about some of the technologies that were handed to us. And then I want to show you some videos to show you how we took that from the technology of the 1970s through to the 2020s. And to give you an idea of what you can do, what your generation should be capable in taking that technology that we're going to hand to you in 2020 and maybe go to 2070 in it. My name is Rick Orzel. I'm a special instructor at Davis Aerospace. And at Davis Aerospace, we are looking for those kinds of students who have the courage and the ability and the aptitude to use the engineering process to solve the problems to advance aerospace and aviation, and maybe even, like we talked about in our last video, interstellar space and time travel. Believe it or not, all those things are hooked together. You start with one equation, which leads to another equation, which leads to another equation. And before you know it, you're figuring out the circumference of the Earth going around the sun, the speed of a, we're talking about lift over drag equations. We're talking about thrust equations. We're talking about relative humidity. All of those things that you have to have a basic knowledge on to have a career in aerospace. Davis Aerospace has been around since 1947, I believe, and it started for returning servicemen coming back from World War II. And that's where I want to start with today. World War II, there's always great advancements in aerospace in times of conflict. And World War II is exactly the way it sounded. It was a world war that went from 1939 to 1945. And during that time, there was great advancements in aviation. There's great advancements in a lot of areas, but aviation is just one of them. And some of those technologies that we're going to talk about that were handed to me, to our generation, were jet engine propulsion, rocket propulsion, and helicopters. Those were all things that were developed during World War II, basically from 1939 to 1945. I started in 1970, so there was some progression of these items between 1945 and 1970. Well, the videos that I'm going to show you basically are around that 1970, maybe just a little bit earlier, but it's to give you the basic idea of the state of these technologies in commercial airliners and rockets going into outer space and helicopters, and how that we've been able to progress that from 1970 through 2020. Davis Aerospace is a high school. And we're going to teach you all of the prerequisites that you need to get into these engineering or aerospace or piloting or maintenance or technical or engineering or design fields. We're going to teach you the basics while you're in high school. I went to Davis Aerospace myself. Davis Aerospace, again, was started for returning servicemen. After I got done with active duty doing the type things that you see on that first video, I came back to Davis Aerospace for my civilian ratings. I had military ratings as a mechanic, but I did not have civilian ratings. So I got my civilian rating, and then the first job I got afterwards was working on helicopters for the Warren Police Department. That's how I got started. So let's start at 1970. Let's start with the early, actually, we're going to go back a little bit more before that. We're going to go about 1950. The technologies from World War II had just been handed to the civilian market. During World War II, we had developed cabin pressurization and jet engines. But that time of conflict is over. And now we have to figure a way of taking those technologies and put them to modern use to make money, to put them into commercial use. One of the very first commercial airplanes that were built was the de Havilland Comet. It's a British company. A guy by the name of Frank Whittle, an Englishman, was one of the founding fathers of the jet engine technology. So it only made sense that the very first jet engine should be English. They were the ones, along with the Germans, the bad guys during World War II, that developed technology. And when we talk about rocketry a little bit later on, the Germans, our adversaries in World War II, were the proponents of that rocket engineering. And they had the engineers that actually broke through a lot of these barriers. And after World War II, a lot of those engineers came to work for us. So we're going to start off with commercial airplanes. So I want to show you a short video on the de Havilland Comet, and they're going to talk about some of the problems that they had with the de Havilland Comet.
In 1949, the Comet 1, the world's first commercial jet airliner, made its maiden flight. Designed and built by British aircraft manufacturer de Havilland, it was seen as the prestigious advance for the UK that was still recovering from the devastation of the Second World War. The British aircraft industry had been focused on military planes. After the war, this expertise, including Sir Frank Whittle, responsible for developing Britain's first jet aircraft, was redirected toward the production of civil aircraft. In 1946, de Havilland began design work on the DH-104, intended to carry mail on the transatlantic route. The new plane would be powered by 4 de Havilland Ghost engines, but because of their low power, it was decided to save weight and use a thinner metal skin. In addition, this first version of the Comet would have square windows, and these two factors led to a catastrophic design flaw that would not become apparent for several years. In May 1952, the Comet 1 began regular passenger service. It was quieter, and its pressurized cabin offered greater comfort. Within months, Comet 1s began crashing in clear conditions, and the plane was grounded. Metal fatigue, exaggerated at the square window corners, had caused catastrophic failure. De Havilland had already been working on modifications, and with the introduction of the new, more powerful Rolls-Royce Avon engines, the new Comet 4 began the first transatlantic jet service. Though the new Comet was a good, reliable plane, the earlier crashes had damaged its reputation, and it now had a competitor in Boeing 707.
Okay, remember what they said right at the end here, the Boeing 707, because later on we're going to take a look at some Boeing aircraft as examples of evolution of our jet airliners. I use this Boeing 787 and the new Boeing 737s as examples of how we've taken that technology of cabin pressurization and jet engine travel and advanced it to the 2000 time frame of 2020. The second topic we're going to talk about is space travel. And how do we get into outer space? Well, we use rockets. Combustion is required for thrust in a jet engine. In a jet engine, we pull the air in the front of the engine, we compress it, we put some fuel in it, we burn it, we shoot it out the back, and that's how we get thrust. But rocket engines are different. Rocket engines have to work in outer space. And there isn't any air in outer space. That means we've got to take our oxygen with us. Oxygen's not easy to take any place. In the air around us, about 18% of it, what we breathe in is oxygen. The rest of it is nitrogen and some other trace elements. Not only do we have to take the oxygen with us, but we have to take a lot of oxygen with us. So we had to figure out how to get a lot of oxygen in a very small space. One of the ways we do that is by freezing it. The colder something gets, the smaller it gets. If we freeze it enough, it actually turns into a liquid. And then if we freeze it some more, it almost turns into a solid. And that's where we pump it into the rocket. Matter of fact, if you see a lot of these rocket launches, it looks like there's steam coming off, and that's actually the oxygen warming up and venting back outside because the oxygen on the inside is still liquid, along with the fuel. When something goes wrong, like you're going to see in this next film, it just doesn't burn. It really blows up. So in this video here, some of these rocket launches are successful, but you're going to see that a lot of them were not. right, so those were the early rocket launches. There's a lot of problems. Some of them made it okay, but not all of them. And the United States is looking for astronauts. We're looking for somebody to get into a capsule on top of that rocket. Well, about half of the rockets we've seen in that video, they didn't last very long. And when they blew up with enthusiasm. All that liquid oxygen gets into the propellant and it just doesn't burn. It grenades, it really blows up. And that's what we've seen in that last accident. You could actually see the liquid oxygen falling out of the rocket and burning up as it was descending. Not very many people wanted to get on top of those things. In actuality, now we've gotten to the point where we are going to start selling commercial tickets to go for rides into outer space. That's how much we have advanced in our knowledge of rocketry. Every time there was an accident, there was a cure, there was a problem, there was something that we got to solve. And these are all the things that my generation has done. We're going to show you the videos now. A little bit later on, I've got one more video to show you on the advancements. The last video I want to show you right now is on helicopters. And like I said, I'm a helicopter mechanic by trade. I'm an aircraft mechanic. I have an inspection authorization. I can sign off the airworthiness on aircraft. And that's what I really do for a living. But in the beginning, mainly what I worked on was helicopters. So a short video now on helicopters. Again, this is circa 1960, 1970. It's a party in a backyard. Now, people can come to a party in a backyard in helicopters. They can't come to a party in a backyard with fixed wings, unless there's a big long runway back there. But you can see here that some of these helicopters are small, some of them are large, but they can all land in the backyard. The very last helicopter in this video is a helicopter type that I actually worked on a lot.
At one stage of the proceedings, the host, Mr. Houston, who also owns racehorses, modestly decided that the guests wouldn't miss him for a few moments. He took off and flew to nearby Kempton Park to see his horse Pre-Fairy running in the 330. From a grandstand view at 1200 Monster with a design as functional as its name, Type 173. It could be that we're witnessing a party of the future. For previous occasions like this have been so successful that it was decided to make this an annual event. The advantages of this form of travel are obvious. Speed, no traffic jams or irritating delays at lights, no bumper-to-bumper crawl home, and no punctures. But that well-worn gag, I'm sorry, darling, but I seem to have run out of petrol, isn't going to be much good.
All right, that last helicopter right there was a UH-12E, a Hiller helicopter. And actually, we still have a customer that every year brings his Hiller helicopter down to us, and we do the maintenance on it. Well, let's make some observations about these helicopters. First of all, they were all driven by reciprocating engines. When it comes right down to it, reciprocating engines are not as reliable as turbojet engines are. There's a lot more moving parts, a lot more that can go wrong with them. And all the early helicopters were powered by these reciprocating engines. They're kind of odd looking too, aren't they? They don't look very aviation. They don't look very streamlined. They're kind of bulbous. They're kind of round. They made a lot of noise. They were kind of awkward looking, okay? They were hard to control. It took a lot of talent. It took a lot of time to become a helicopter pilot back then. Those were all the things that, but what it did do is it hovered. It could land in somebody's backyard. Early on, there were a lot of helicopter accidents also. I didn't want to show you those. We need to move on here. But suffice it to say that there were a lot of things that went wrong with the very early helicopters, just like there were a lot of things that went wrong with the very early jetliners and the very early rocket ships. But my generation took those challenges and solved a lot of those problems. We went on to build airplanes like the 787, the 737, which are Boeing. Now, remember that at the end of that first video, it said that when de Havilland Comet 4 came out, it had a competitor, the Boeing 707. That family of airplanes is still in existence. Okay, and they're still building aircraft today. Then we went into rockets, and we seen that there were a lot of rocket ships that were that did not survive. And to be quite honest with you, one of the developments, all of those early rocket ships, even if they did what they were supposed to do, you could only use them one time. If they blasted off and got their satellite into outer space, the rocket engine itself disintegrated, coming back into the atmosphere. We couldn't reuse it. Imagine that. If every time we got onto an airplane or every time we got into a car, you could only use it one time. If you're getting in your car and going to the store today, coming back, you have to get another car for tomorrow. How inefficient is that? Well, it's very inefficient. It's very expensive, and it made getting satellites into outer space very expensive. We don't do that anymore. We've actually designed rocket ships that land, and we can reuse them. And it's getting to the point now where we're actually selling tickets to go into outer space as passengers. So those are the advancements. Now, let me just recap a little bit. Jet engines and pressurization came to my generation from the generation before, World War II. Frank Whittle, got one of the fathers of the jet engine. And then came rocket engines. Rocket engines were mainly used by our competitors, the people during this time of conflict, World War II, the Germans. They were the Axis power. They were the bad guys. And their guy was a guy named Wernher von Braun. After World War II, Wernher von Braun came to work for the United States. And he was actually the father of the United States rocketry and the Saturn V that in 1969 pushed a rocket all the way to the moon. John Kennedy is the guy, I think I've talked about this before, that challenged the Russians to send a person to the moon and bring them safely back. And they did that in 1969. The guy that designed the rocket was Wernher von Braun. He was a leftover from the German Nazis that started the V1 and V2 projects during World War II. And then another technology was helicopter technology. Helicopter technology also came to us after World War II. It was designed right toward the end. It was designed for jungle fighting, where we could take this helicopter into the jungle and get wounded out of the jungle earlier, faster. In a jungle, it's very hard to go through a jungle. If you can pick them up and fly them out, we can get the wounded back to the hospital very quickly. We can drop supplies into the jungles, Southeast Asia, think places like that. When we were fighting the Japanese at the time, that's where we were using the very first helicopters. So these are all three technologies that came to us from World War II, from that time of conflict. There was some development that went on, and that development led to the Comet. And then there was rockets, and that development led to the first of the Mercury, and then the Gemini, and then the Apollo program, and finally it went to the moon. And then with helicopters, okay, again, the first developments with Bell Helicopter and Sikorsky were for the military. Now we use helicopters in the Coast Guard for air ambulances, for police surveillance, for all sorts of things, for putting out forest fires in California, pipeline patrols, all sorts of things we use helicopters for. We're going to start off with showing you the new jetliners. And I want you to try to recall what the old jetliners look like and what these new jetliners look like, okay? These are videos of the Boeing 787 and 737. All right. So what do those have in common with the old de Havilland Comet? Well, they both had jet engines, but the de Havilland Comet had something known as a turbo shaft engine. Okay, it was it still pulls in air, it still compresses it, it still pushes it out. There's still combustion, it still pushes it out. But now what we have is called turbofan engines. And these turbofans actually turn a large fan, which pull a lot more air and have a lot more thrust. They're a lot more efficient. They burn a lot less fuel. They're a lot quieter. So there's been a lot of advancements from the earlier turbo engines to the turbofan engines. They lose less, like I said, they use less fuel. So they're greener, they're more friendly to our atmosphere. The 787 is not built out of aluminum. Remember how they said earlier with the de Havilland, it was built out of aluminum because the engines weren't very good. They had to use a thinner gauge metal. 787 is not built out of aluminum at all. It's carbon fiber. It's basically a very, very, very strong plastic, very light and very strong. We can build airplanes quicker with them because the pieces are made in larger pieces and then assembled, as opposed to all the pieces having to be riveted and cut and bent and put together. The 737, the smaller aircraft that's in that video, is more of a conventional airplane, but it is starting to use more and more composites. The majority of that airplane is still made out of aluminum, but it also has the turbofan engine, which means that it is also much more efficient. So what are the advances? Cabin pressurization. We fly easily at 40,000 feet. The windows are much more rounded off. We actually have larger windows in the airplane, and they are not susceptible to the same stresses as the earlier de Havilland airplane. We have turbofan engines, okay, which are much more efficient than the older engines. We can fly higher, smoother, and on a lot less fuel. And it's pretty comfortable. The higher we are, the more comfortable we are. So that, in a nutshell, are all the advances that we made in, not all the advances, but an example of the advances that we've made in commercial airliners. The next thing I want to show you then is rockets. Now, we remember the early rockets, they weren't very good. About half of them blew up. We got to make these things reliable that astronauts are going to want to get on top of them and go into outer space and eventually to the moon. We've got to get them a lot better. And not only do we have to get people on them, but we've got to get the payload. We've got to send those spaceships into outer space that the astronauts are going to get into and actually go down to the moon. Means we have to have some pretty large rockets. And you got to remember that even in the 1970s, after we've got our rockets fairly reliable, they were still only a one-time use item. We couldn't use them over and over and over again. Now, one of the videos that I didn't show today was on the space shuttle, and that was actually a space airplane that we would launch on a rocket into outer space, and then it would fly back into the atmosphere. There were some problems with that one too. And we are looking at newer types of space aircraft, like the space shuttles. But what I want to show you today is Blue Origin. When you take a look at it, you're going to see some similarities to those very early rockets, but you're going to see some differences too. One thing is the rocket is a lot smaller, and the space capsule on the top is a lot larger. That space capsule can take up to 6 people. When you see it in this video, it's a much cleaner looking flame. It's more precise. It's precisely engineered. And the thing of it is when you watch this video, after it gets into outer space, the rocket comes back and lands. The most important thing here is that this rocket is reusable. We can refuel it, we can refurbish it, we can inspect it, and we can do it again with the same rocket. The earlier rockets, every time we used one, we had to go get another one. Can't imagine if every time you got in your car, you could only use it one time, but that's the way it was in the very early space race. So what I want to show you now is a test of the Blue Origin. The actual Blue Origin is probably going to go sometime in the next week. This is July of 2021. Sometime in the next week is going to be the first commercial flight of the Blue Origin. last week, we actually did have a space plane. Virgin Galactic it went into outer space with some customers on board. So we're getting into that now, that we are getting into outer space so reliably that we can actually take passengers and that spacecraft that are reusable. So those are the advancements that my generation has made. Let's go ahead and take a look at the Blue Origin spacecraft. Notice toward the end of it that the aircraft actually comes back and lands.
All right, look at her go. Mission Control has confirmed New Shepard has cleared the tower. Check out that shot from our drone. On her way to space. Lunar landing tech on board. Payloads inside. Beautiful. There we go. All right. Come on, New Shepard, let's go. Wow. Look at that stability.
So stable.
Touch
Oh my God.
down. New Shepard, here we
incredible.
go. All right,
There
and
it is.
touchdown of the capsule. All right.
You made it back. Excellent.
Woo!
All right. So we've seen the rocket itself, the rocket motor, come back and land. When it got into outer space, the space capsule did deploy from the rocket, and that's the traditional way of doing things. Everything doesn't go up and come down together. The space capsule departs, and a lot of times that space capsule goes into orbit. It might join the ISS. This one here isn't designed to do that. It's actually designed just to take paying customers into outer space so that they can say that they've done that. It's a joyride. It's like going to your local airport and going up and flying around the pattern, like our Young Eagles programs. That's basically the same thing, except for going to outer space to do it. It's relative. It's a lot safer than what it used to be. The technology is a lot better. You could see that when the rocket took off, it burned a lot cleaner, and you can see that the rocket actually landed and how stable it was when it landed. Everybody on board, there are 6 people on board. There's 6 large windows in that capsule, and it's weightless, I think, for 6 or 7 minutes when it gets into outer space. It actually goes so high that when you look up at the sky, it's black. There's no blue because all of the atmosphere is below you. You can actually look out and see the curvature of the Earth. That's what my generation has been able to advance through to when it comes to space travel, when it comes to rocketry, when it comes to aerospace. Last thing I want to show you is helicopters. And helicopters is what's nearest and dearest to me. Through most of the first years of my career, I was strictly a helicopter mechanic. Eventually, I got to work on fixed wings, and eventually I got to work on larger aircraft, and eventually I worked on just about every kind of airplane there is, really. Big airliners, smaller airliners, corporate aircraft, helicopters. There's a lot of variety in aviation. I want to show you the newest version of a Sikorsky helicopter. It's called the S-97, I believe, the Sky Raider. And then we'll talk a little bit about the things that were the same as those early helicopters, those awkward helicopters, those loud and bulbous helicopters that were in that first video. And then let's compare it to what we see with this newer Sikorsky helicopter. Again, some of the things are the same, but a lot of them are different.
My name's Christian Corey, and I'm an experimental test pilot at Sikorsky Aircraft. In the Raider program, I'm sort of one of the guys that has the opportunity to fly the aircraft, but also participates in some of the developmental meetings and the design. How do we get to the next step? So it's a bit of what we do. You could do things where you'd want to target something, for example, and you can sort of hang there better than on a traditional helicopter. It gives you more flexibility in how to operate. Straight up, like, speed is going to be the advantage. It's a lot faster than you can go in a traditional helicopter. On X2, you're able to go faster without rotating the fuselage. So it's a level attitude that you maintain throughout, you know, your speed sweep, if you will. I think the biggest difference between a fundamental, like, traditional helicopter and the X2 is that prop that's on the back, right? It's taken really, like, the best part of a vertical, a STOVL, like a Harrier, or the new Joint Strike Fighter that can, you know, it's this jet that can take off or land vertically and then go forward. X2 and the Raider can do that indefinitely, the same as a helicopter, until it's time to go fast, and then it operates better in that regime as well.
Forget everything you know about helicopters. X2 technology combines the best elements of low-speed helicopter performance with the cruise performance of an airplane. It's going to change the game.
So let's take a look at the things that are the same. It can hover, it has rotor blades. We notice that the S2 has counter-rotating rotor blades, two sets of rotor blades that are going in opposite directions. And because of that, it doesn't need a tail rotor. Let's remember that those early helicopters were quite bulbous. They weren't very aerodynamic. The new Sikorsky helicopter actually has a retractable landing gear. It can fly much faster than the old helicopters, about 100 miles an hour. Newer helicopters, 200 miles an hour. The older helicopters looked awkward, and I didn't see anything that looked awkward in this new helicopter. It looked very precise. It looked very stable. So those are the developments that my generation has made in helicopters. First, we've seen the developments in commercial airliners. Then we've seen the developments in Rockery. Now we see the and boys and girls, ladies and gentlemen, hopefully future students at Davis Aerospace, there are many, many, many more facets of aviation that have also been defined and refined in my generation. So we're looking for the students that want to advance it further, that want to come up with the next generation of rockets, the next generation of commercial airliners, hyperspace airliners, faster, smoother, more reliable helicopters. Those are the things we're looking for at Davis Aerospace. Now, again, Davis Aerospace was started in 1946 for returning servicemen. Service, the military is a way after high school that you can get a lot of military training, that you can get a lot of aviation training, but not necessarily the only way. And it's not for everybody. What we've looked at today is three different kinds of helicopter, or three different kinds of aircraft: helicopters, rocket ships, and commercial airplanes. But we are teaching the prerequisites to a lot of different professions: engineering, electrical engineering, drone pilots, fixed wing pilots. aircraft mechanics, aircraft engineering. Those are all the things that we are teaching the prerequisites to at Davis Aerospace. Those are the kind of students that we're looking for. Okay, so I'll tell you what I'm going to do right now. I'm going to put my helmet back on and I'm going to go look for an old helicopter to go fly in. Because when we get into this stuff, it really is a lot of fun. The development, the research, the reliability, and it's a great way to make a living. My name is Rick Orzel. I'm a special instructor at Davis Aerospace. And if any of this stuff that we looked at today interests you, give us a call. If you have any questions, give them to your teacher. They'll forward them to me, and we'll see if we can take care of them for you. After this lecture, next we're going to get into the different professions you can have in aviation, like mechanics, like engineering, like air traffic controller, like servicing, like being a pilot, things like that. So I'll see you in the next presentation. Thank you very much.